4.4, trig functions at any angle. What we should learn: evaluate trig functions of any angle, find reference angles, and evaluate trig functions of real numbers. So we kind of talked about this before when we did the unit circle, but now we can do it for any angle. It doesn't have to be a unit circle. What's the one difference? When we did the unit circle, right, wasn't it sine of theta equals y, cosine of theta equaled x, and tan of theta equaled y over x? Well, in that case, the r was 1 because it was a unit circle. 1. These are all being divided by 1. But what happens when when the radius is not 1? Well, then you just divide each. So when the radius is not 1, you just divide everything by r. Right? We lucked out before because r was 1, made it a little easier. But when it's not 1, you just got to remember to divide by r. And it doesn't affect tan because tan didn't do anything with the radius. It was just y over x. It was just opposite or adjacent. So that's the one difference. If you're doing it when it's not in the unit circle, you just got to divide your y and x values by r. So let's do an example real quick. Let negative 34 be a point on the terminal side. Find sine and cosine tan of this. So we're going to find sine, cosine, and tan of theta. So we're going to do the same thing we did before. We're going to build a triangle. We're going to figure out the sides. Now remember, this is an xy point, so we went left 3. Well, negative 3 technically went, and then we went up 4. Right? Keep in mind we went left and up, and it's a negative, so we went to the left. Hypotenuse, right? It's a 3, 4, 5 triangle. Right? Save yourself some time if you know your special triangles. If not, a squared plus b squared equals c squared. Let's label the sides. Here's my angle. So this is opposite, adjacent, and hypotenuse. Now, SOHCAHTOA, right? Opposite over adjacent. So this opposite over hypotenuse. What's wrong with me? Opposite of hypotenuse, 4/5. Right? Notice it's being divided by the hypotenuse. When you do the unit circle, hypotenuse is always 1. But if you're just doing a normal triangle, it works out. Map's so great. Cosine SOHCAHTOA. So adjacent over hypotenuse, negative 3 over 5. And tan TOA is 4 over 3 over negative 3. So that's the way it works. So if you know how to build your triangles, you're all set. Let's talk about the sine chart. So when we do our unit circle stuff, in quadrant 1, right, here are our sides. We go right plus, and we always go right is plus and up is plus and our hypotenuse is plus. So no matter what combination I do, all of them will be positive. Sine, cosine, and tan. They're all positive in quadrant 2. So shortcut, we'll put a little a here because they're all positive. Look at there. In quadrant 1, I don't know why I was saying quadrant 2. In quadrant 1, we go left, it's negative, we go positive and positive, right? Hypotenuse is always positive. Well, that makes cosine negative and also makes tan negative. So only sine is positive here. Right? So you can see right here, right? Sine is positive there. So they go S because only sine is positive. And keep on doing that. In this quadrant, we go left and down, hypotenuse is always positive. Only tan is positive because you're doing the ratio of opposite over adjacent. Those are both negative. You get a positive tan. T, that's why the tan one's positive there. And in quadrant 4, the negative is going down because they're going down in that case. So that makes sine negative and it makes tan negative, but cosine is positive. So that C is the only one that's positive there. So for a shortcut to memorize where stuff's positive, in mathematician we generally go AST, ASTC. So let's just know that in quadrant 1, all of them are positive. In quadrant 2, only sine is positive. So if you're in quadrant 2, sine should be positive, the rest should be negative. Quadrant 3, tan is positive, the rest are negative. In quadrant 4, cosine is positive, the rest are negative. And a shortcut for memorizing that is all students take calculus. Again, you can make up your own mnemonic, but that's like the famous math one, is all students take calculus. So we know, oh, it goes ASTC around. And again, that lets you know which one's positive in that quadrant. So let's do a problem that's solved. Use that to solve. Given sine of theta equals negative 2/3 and tan is greater than 0, find cosine and cotan. So what we're going to do is build a little triangle, like I always like to do. We know a couple things. We know sine is negative, right? So if we do all students take calculus, sine is negative, so we can't be in quadrant 1 or 2 because sine is positive in those two quadrants, right? A stands for positive, all positive. S is for when sine is positive. Tan is positive, so it must be quadrant 3 because that's the only one where tan's positive and sine's negative. So that's our triangle. And what else do we know? It's sine, SOHCAHTOA. Opposite over hypotenuse. Opposite should be -2. Hypotenuse should be 3. I gotta find cosine and cotan. Well, I need the adjacent side to find cosine. So we're gonna have to do the Pythagorean theorem. A squared plus b squared, which is -2, equals 3 squared. So I get a squared plus 4 equals 9. A squared equals 5. A equals plus and minus radical 5. Right, since we're solving, it's only be one of these. Which one is it? We're going to the left, so it should be a negative rad 5. So if I'm doing cosine, also if you're not sure, you don't have to do, if you're not sure about the going left and going down, you don't have to do that anymore. You're in quadrant 3. What's the only thing positive in quadrant 3? Tan and cotan, because tan is cotan is reciprocal of tan. So if you're in quadrant 3 and you're cosine, you must be negative because everything's negative in quadrant 3 except for tan. Anyway, cosine SOHCAHTOA, so adjacent over hypotenuse. So negative radical 5 over 3. And then cotan is the opposite of tan. Tan is TOA, opposite over adjacent. So we just got to flip it, adjacent over opposite. And the negatives cancel out, so we get this. So that's how we do it. Evaluate the sine and cosine functions at angles 0, pi over 2, pi, and 3 pi over 2. That's a lot of them. Let's just do 3 pi over 2. So let's just do that one. So here's 0, here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. So remember, we've done these a couple of times. When you land on one of the lines, it's called a quadrantal angle, and you do not make a triangle. What you do is, you remember it's a unicircle and you use a point. So this would be point 0, -1, right? Because on your x you didn't go anywhere and you went down 1. That's my x and my y. If I'm trying to find sine and cosine, I'm doing sine of 3 pi over 2 and cosine of 3 pi over 2. Remember, sine is always the y value, which makes cosine the x value. So at this point here, cosine is 0 and sine is -1. So that's how you do all these. You do it everywhere. Like this would be 1, 0, so sine would be the y value, cosine would be the x value. You do it at every single point. Reference angles, again, it's another thing we talked about. The reference angle is just how far you are from the horizontal axis. How far are you from x? That's it. So if you look at here, right, if I draw angles like that, reference angle is how far these two are apart. Down here, how far are these two apart? It's just how far are you from the x-axis. That's all the reference angle is. So if I'm drawing a reference angle on some of these guys, 300, here's 0, here's 180, here's 270, here's 360. 300 will be in here somewhere. That doesn't really matter. And then you just draw the reference angle. This is my reference angle. So 300, 360 is 60 apart. That's a reference angle. 2 pi over 3, honestly, I have my radians down like this. I don't have what that means in like numbers terms. I would say this is pi, which is 3.14. So 2 pi over 3, this is 3.14 divided by 2, so that's like 1 point something. So it's probably in here somewhere. So it'd be in there, would be 2.3. And what's the reference angle? We got to go down to here. You got to find that angle. Now remember, when you're doing this one, like if I was over here, it would be 180 minus the angle. So same idea here. This would be pi minus 2.3. Also, pi is bigger, so you just do that one. So whatever that is, 3.14 minus that. So like point something. Let me do my calculator. Doesn't do it in my head real quick, and I probably shouldn't. Pi minus 2.3. Right, reference angle should always be positive, so if you're not sure, just subtract and make it positive. We'll say that. Right, so think about that, reference angle should always be positive. It's always a positive value, because it's a distance. And it'll be the same thing with that one, so I'm going to skip that one. Trig function row numbers, we kind of talked about this already, but let's do more examples. So evaluate cosine of 4 pi over 3. Right, so we did this in the previous lesson, but the process for me is, if you can memorize the unicircle if you want, I like to build triangles. So I'm going to build a triangle for 4 pi over 3. So I'm going to draw my little unicircle. Here's 0, here's pi. Here's 3 pi over 2. I don't need that one. Here is 2 pi. I like to get the common denominator. We're over 3, so we're going to make this 3 over 3. 6, and that's the same as saying 6 pi over 3, right? 6 pi over 3 is just 2 pi. Where's 4 pi over 3 at? So if we're starting from here, and we're positive, we're going up, right? This is 3 over 3. We haven't hit 4 pi over 3 yet. We're going to go a little bit past it, so we must be in quadrant 3. That's 4 pi over 3. Make a triangle. The reference angle, remember, you're in radians, the reference angle should be known. Pi over 3 is always 60. Pi over 4 is always 45. And pi over 6 is always 30. Right? I know these sound like they're opposites, but when you divide by 3, you get big slices. When you divide by 6, you're getting a small amount because you're dividing by a lot of people. So dividing by 6 gets you something small. Dividing by 3 gets you something big. Anyway, once you're here, so we know pi over 3 is 60. If you're doing the triangle method, you have to know your 30, 60, and 45, 45, 90 triangle. So 60 is big, it gets the rad 3. Hypotenuse is always 2. This is 1. Now, there's 2 ways you can do this. If you're pro, you kind of memorize, okay, we went to the left, so it's a negative. You went down, so that's a negative. So all I got to do is figure out what cosine is. Cosine will be SOHCA, TOA, adjacent from hypotenuse, negative 1/2. If you don't like doing that for the negative sign, you can always just do, all students take calculus. We're in quadrant 3. Only tan is positive. The only way you could get a positive here is if you're doing tan or cotan. So everything else should be negative. So that also works. Let's do B, tan to negative 120. So here's 0. Here's 180. Remember, it is negative, so we're going to go down. So negative 90, negative 180, negative 270. Where's 210? Negative 210, sorry. You have to go this way, so you're going to be in quadrant 2. So remember, you start here and you go back 210. So again, always go down to the x, never to the y. This is 210, and that's 180. They are 30 apart. Hopefully the other side's memorized, so it's 1, 30 small, rad 3, and hypotenuse is always 2. And then again, if you either know that when you went to the left it's negative, when you go up it's positive, hypotenuse is always positive, or you do all students take calculus at the end. We're doing tan, so TOA. So opposite over adjacent. So 1 over negative rad 3. Or again, right, we're in quadrant 2, only sine's positive in quadrant 2. So that also tells you it's negative. Okay, cosecant of 11 pi over 6. So cosecant, I need to draw it. We're going to do C here. Here's 0, here's pi, here's 2 pi. This is going to be 4 over 4, 8 pi over 4. So we have 2 choices, right? That's too big. You can either subtract 2 pi and get something that's coterminal and do it that way. That would work. Right, you go minus 2 pi over 1 and do a common denominator. You get 3 pi over 4. So you can do it that way and just graph that, or you can keep on going around. This is 4, that's 8. This go around again, you get 12. That means 11 is a little short of that, so right here, quadrant 2. Same thing as 3 pi over 4. So any way you like to do it. Make a reference angle. Over 4 is automatically 45. So we get 1, 1, rad 2. That one's negative because it goes to the left. And I want cosecant. Cosecant is opposite of sine. So you're just going to find sine and flip it. Sine is SOHCA, so. So opposite over hypotenuse. And then we just flip it for cosecant. So radical 2. Or again, if you want to think about it, right? We're in quadrant 2, only sine's positive. That's why my value is positive. Okay, trig identities. This is another one where I don't actually use trig identities. I just make a triangle. I think that's the easiest way to do it. So use let theta be an angle in quadrant 2 such that sine of theta equals 1/3. Find cosine. So all we're gonna do is this. So let's draw a triangle in quadrant 2 like it says, like that, right? And I know a couple things. Well, I know one thing. I know sine is 1/3. So SOHCA TOA. So opposite is 1, hypotenuse is 3. So opposite is 1, hypotenuse is 3. And I could use that to find the missing side. Right here, right? So we're going to go a squared plus b squared equals c squared. So remember, a and b don't matter. We'll say that's a squared plus 1 squared equals 3 squared. C has to be hypotenuse, that's why it's 3. So I get a squared plus 1 equals 9, minus 1 minus 1. A squared equals 8. Take the square root. A equals the square root of 8. Or if you want to break it down, 8 is 2 times 4, which is 2 times 2. We have a pair of 2's. So you can also say 2 square root 2. I'm kind of fine either way. We'll put 2 square root 2. It's a little fancier. Now, again, two choices. You went to the left, so that's negative. Or at the end, you could check all students take calculus. Either way, it's fine with me. I want to find cosine. So katoa. So adjacent over hypotenuse. So cosine of theta is equal to negative 2 rad 2 over 3. Again, if you weren't sure about the sign, at the end you can always do all students take calculus. And we are in quadrant 2, so only sine's positive, and we're trying to find cosine, so it must be negative. And that's the lesson.